We start with this. What is the width of the entire interval? 3. So what's the width of n rectangles? That seems simple. So as you consider this, we would be starting at the number 2, and you'd be heading all the way over to 5, right? And so, you know, in order to get your first term, you would move over one width, right? You'd move over 3 over n. And then you'd move over again, you'd move over a second width. You'd move over a total of 3 over n again, which is 2 times 3 over n, right? But you have to add 2 to each of those, don't you? So therefore, where do you evaluate the sum for what x values? We evaluate the x values at 2 plus 3I over n. That's why we have the 2 plus, because we don't start at 0. So I just represents which rectangle we're adding up, and we go there. So what does the integral look like? 2 to 5. Hey, before we do anything else, there's a constant here. So how much is that going to add to the overall area? 12, because you have a width of 3, you have 4. That's going to create a bottom rectangle of 12 if you looked at the graph. If you were to count, if you were to try to graph this and just count them up, that would be your 12. You'd count up right away. Just so you saw it, you made the connection what I talked about earlier. Good for you. You're very smart. Limit as n goes to infinity of the sum from I equals 1 to n of, gonna get bad, isn't it? Gonna put a big parenthesis down. 4 plus 2 plus 3I over n. Very good. So Bailey remembered times the 3 over n. That's often a piece that gets left off. You get used to writing the other pieces. Do you need another thing of notes? We're going to keep our day. Way to go. So, just to be clear, I did ask you guys how much extra area will be added because of that 4. You told me a total of how many? Total of 12. Just notice that this 4, that it will end up being added to some other pieces, won't it? And so you won't see the 12, but it is carrying through all the way there. So let's do a little bit of algebra. Limit as n goes to infinity, sum from I equals 1 to n of, I'm going to just try to get rid of these inside parentheses, so it's going to take a while. 4 plus what? 4 plus 6I over n minus 1/2. Shoot, I got to square all that out. Man. I got to multiply that out. 3I over n times 3I over n. 9I squared over n squared. There's no easy way of doing this. Then I'm going to have that times that, right? It'll be 6I over n, and then double it to get 12I over n. Yeah, so when you take this multiplied by itself, you're going to take 3I over n times 2 to get 6I over n. And then you have 2 times 3I over n to get another 6I over n, which makes my 12I over n. And then you'll have what? That 4 guy on the end there, right? And then all of that, as Asher said, times 3 over n. Ugh. Yeah. Limit as n goes to infinity of the sum from I equals 1 to n of, yeah, do you guys want to just do the 4, or do you want to also distribute the half? What do you want to do in this step? Okay, so I'll cross off terms. So we've got 4 and 4 makes 8, and then negative 1/2 times 4 will be negative 2, so I'll end up with 6. So I've got 6 plus then 6i over n, what am I going to be able to join that with? 12i over n times a half, right? They cancel. All right, cool. Look at that. Boy, whoever selected this problem was sharp. All right. And then it looks like we just got minus 9i squared over 2n squared times 3 over n. Hey, that's not that bad anymore, is it? Yeah, sometimes terms really cancel and combine. We're very fortunate. Limit as n goes to infinity of the sum from I equals 1 to n. And we've got 18 over n minus 7i squared over 2n cubed. We all okay there? Yeah, now it's a piece of cake upside down. We'll just split it into two parts, two sums. Limit as n goes to infinity of the sum from I equals 1 to n. And I'll put the 1 over n out front. So what am I left with then? 18 minus sum from I equals 1 to n. What do you want out front? 7 over 2n cubed. And what do I have left in there? I squared. So the limit as n goes to infinity of 1 over n times what? 18n. Willie says this guy right there, it's got a constant, just ends up being 18n. And I try to explain why, due to the rectangle thing that's going on. Because we got the 12 captured in there, but we got other pieces too. But that's why we just end up with that constant, okay? So those are obviously going to cancel. Minus 27 over 2n cubed times what is replaced with the sum from I equals 1 to n of I squared? Yeah, it is that guy, isn't it? Yeah. N times n plus 1 times 2n plus 1 all over 6 or limit as n goes to infinity. 18, that makes me smile. Minus, what do you want to cancel? Okay, so we'll get rid of that and get rid of one of those. Do you want to do 27 over 6? Want to reduce that? Get rid of a 3 out of that, so 9 over dos. Spanish for 2. I was inspired today. I met a Spanish class. They came to, I sit at the lower Locker Bay area, and there's art behind me. Yeah, and they're coming to kind of look at the art. Josie's sister was with them, and the Spanish teacher, what's her name? So she said you need to write comparison statements about the art. There's 7 pieces of art here. Some student calling 7. They're like, well, what about Gantz? She's like, he's not a piece of art, which I kind of took offense to. Is that kind of a way of saying I'm ugly? Isn't that? Oh, come on. Okay. So Ishika is given an opportunity to correct the statement, and she's now saying that, yes, you are a piece of art, Mr. Gantz. You're just an ugly piece of art. Wow. Just shut up. Whatever. I'm done. Oh. All right. We all heard you. We're witnesses. All right. What do you get on top here? Yeah, 2n squareds I'm going to have 18n squared plus, oh wow, because you got the 3n in the middle times a 9 is a 27n. 9. Over what? 4n squared. Oh, this is where it gets exciting. We get to cancel stuff off. It's Christmas. Factor out what? 18 plus 27 over n. 9 over n squared. All over 4n squared. What happens? N squared's gone. 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 18 minus 9 over 2, or 36 over 2 minus 9 over 2 is 27 over 2, which 13.5. What are the chances we're actually right? Hi, Belschnickel. I go to my calculator, I turn that bad boy on, go into y equals, and what is it? It's 4 what? And I do number 7. I look at the graph, and I'm going from what to what? 2 to 5. 2 to 5. Before I let you work, can I remind you at the very beginning of this unit, we said we were going to use this as a formula, right? Width times the sum of the heights, right? Isn't that what we said we were going to set out to do? So you tell me what has happened to the width of our rectangles. So it goes towards what? 0. Tell me, how many rectangles do we have? An infinite. So if we're adding up the heights of an infinite number of rectangles, what's that sum going to go to? Infinity. What is 0 times infinity? In this case, it's 13.5. Like, that's what we did, folks. We talked about 0 divided by 0, right? We're like, oh yeah, we'll figure that out. We also talked about, well, what's infinity divided by infinity? And we figured that out, that sometimes they're different numbers. Turns out that 0 times infinity as well. It's like, what is it? Which one wins out? Because this is pretty powerful, right? Like, 0 is powerful. But that's pretty powerful too, right? It's like, well, which one's going to win? 13.5. You are now capable of finishing the rest of your assignment. And by the way, this thing that I showed you how to do right here, that you're going to be able to use that on the AP Calculus exam. You'll be able to go second calculate number 7. Okay? You will. So